I'm sorry. That's all. I mean, that's just there's. I think they should just do away with Skype and just call it Skype for Business. All right, there it is. Draw you. This is a continuation of what we were doing the other day. Now we still haven't finished 8.4, but I'm just going to give you a couple of problems to refresh on, and then we'll move on to the rest of 2.4. This is. Go ahead and draw your free body diagram. And I don't have my thing turned on. You're going to have to draw a better one than that because that one's too small. So let me freeze the screen and I'll be pulling up so you can write down everything. Whiteboard. New. And clear. And then pull that back up. There. Okay, so draw a big triangle. Now they are telling you that theta is 46 degrees, 30 minutes. Okay, so that means that the hypotenuse is given as 10.5 meters. So, and I just tell everybody just to find everything. So, this is one of those problems where you get out of it what you put into it. If you go through and do these problems and just find what you need to find, then don't cry when you miss a lot on the test. But if you do these problems and find everything, you should be very good on the test. So, this over here is the opposite. Little man is right here. Little man always has his foot on the hypotenuse and the adjacent. So, I've got an angle and I've got a side, so I can do something with it. Let's do Oscar had sine of 4630 is equal to Oscar, we don't know, over 10.5. Multiply both sides by 10.5. And the opposite is equal to 10.5 times the sine of 4630. So take your handy-dandy calculators and work out 10.5 times the sine of 4630. Make sure it's in degree mode. And what do you get? Move this over here. 10.5 times the sine of 46. Where's the degree symbol I told you? Where is it? Is it under math? Okay, it's what? Second apps, thanks. Oh shoot, I forgot to add 2 people to Skype. Where is second apps? I can't find it. Oh well, I can't find second apps. Should be second something else. Second what? Angle. Angle. There we go. There we go. That's why it's easier to use a TI 30 on these. And 30 second angle minutes and close parentheses and enter. So write that down, 6.13. Well, I add 2 people to the group. Forgot to add them. Crittenton and Fuller. See if she's. And let's see who else. Let me check my text messages. Stores. I should have reminded me to add these people. I suck. Stores. And my phone's on silent. I usually put it on buzzer. Okay, who is that? Crittenton, I got him. Miss Mitchell. And Elise. I can't stand when it does that. And I think I saw her. There it is. Let's see, who else? Mr. Barnes. Well, I tried Fuller. She didn't come up. All right. Stores. Check him again. All right. Stores. Crittenton. Mitchell. Barnes. And Fuller. There should be 5. Okay, Fuller is not. I'm going to send her one text and then we'll keep going. Okay, can all of you see my screen?
I can.
Okay.
Yes.
Okay.
It's still loading.
Okay. Mr. Barnes? Can you see the screen? My screen? Mr. Barnes? Okay, there's Miss Fuller. Okay. Did you say yes or no?
I said yes.
Okay. You need to tone it down, Mr. Barnes. You're a little too loud. All right. Wait on Miss Fuller. Miss Fuller, can you see the screen?
No.
Okay. Give it a second. Is it still loading?
Yeah.
Let me know as soon as it asks you for permission. It should ask you for permission or something. What does it ask? I never see that side.
It says, would I like to use my cellular data because I'm doing it on my phone.
Generally,
But
from
ask me.
on my computer, it doesn't ask me at all. Like usually, when I just get in, it doesn't even ask me. It just shows up.
Huh. Well, I know on the Polycom class it asks. It says something about certain data or something, or do you want to proceed or something. All right,
Yeah,
so can you see the screen now,
No,
Ms. Fuller?
No, it's still not showing.
Okay, I'm going to represent. Okay, see if that helps. You may have to go to your computer, Miss Fuller. Have you tried your phone before?
Yeah, I normally do it on my phone because I'm at school still.
Oh, okay. All right, well, I'm going to move ahead, give it a few minutes, and just let me know if it doesn't work. Just say, hey, Hubert, it ain't working.
Oh, okay.
It should work, because I done presented twice. All right.
Yeah. Okay.
We're doing this problem. This is the first problem we're working on in the class. So we just found the opposite. Is this still on freeze? Yes or no? No. No, it's not. Okay, so the opposite is equal to, what was it equal to? 6.13. So oh my Lord. Is today just the day where everything goes haywire? It's a conspiracy.
It's the Russians.
That's it. It's the Russians. And Comey. And white women.
No, we need to go deeper in our conspiracy theories.
Well,
The
yes.
lizard people.
Yeah, the lizard people. Exactly. Well, she hadn't blamed them yet. She's only blamed Comey and, oh gosh, she's blamed everybody. Says that white women wouldn't vote for her because their husbands wouldn't let them. That's what she said. Huh? Yeah. She blames everybody. Oh, I'm sorry. Just speak out next time. Yes, ma'am.
7.62.
Okay. Did anybody else get 7.62?
I did.
Okay. Well, let me check the computer calculator and see if it's in rating mode.
I don't think you said for the
Oh, I didn't. 10.5 sine of 4630. Mode. And it's in the wrong mode. That's why I told y'all to do it, but I didn't check. I thought it defaulted to degree mode. I thought these computers, I thought they defaulted to it. So, all right. So now I hit second entry. Clear. Second entry. There we go. 7.62. Thank you, ma'am. Now that you corrected me, you're going to fail. All right. You know the worst thing about a teacher making a mistake? A teacher making a mistake and not admitting that they made a mistake, and they try to say it's right. You ever had somebody do that before? You know, y'all don't have any. Y'all don't do anything. Y'all don't respond. 7.62, right? Now, how can we find side A? Well, you can find it by using trig, or you can find it by using Pythagorean theorem. I don't want to type all that in, so I'm just going to do trig. So cosine of 4630 is equal to, Oscar had a hump, A over 10.5. Multiply both sides by 10.5. And somebody crank that out and round to 2 digits. $7.23. Did everybody get that? Now, what's the third angle? Well, 90 subtract 4630 is dang old 30, excuse me, 32 or 33, 30. Somebody check my math. No, it'd be 4330. Somebody check me. Now, you spent a little bit of extra time, but what do you have? You have everything you need, and even though you didn't need all that stuff, what did you put in? You put in extra what? Practice. Oh, gosh. I'm telling you, today is just not. There we go. Now, I'm going to be honest with you. The more practice you get on these problems, the better off you're going to be in statics, dynamics, physics, and calculus. The more you do them over and over and over. All right, now what do they ask for? Find the distance the ladder goes up the wall. So that would be 7.62. And notice I didn't even look at the problem. I just wanted to do the practice, and that's what you should be doing. 7.62. And I hope I got it right. And next question. We're just going to go through several of these questions. That's the same type question. Trying to find a different. Come on, you can do it. There we go. All right, let's try this one. This one is a horizontal. See the horizontal? See the tunnel? That's a horizontal question. I wish this thing was smaller. Okay, can do that. All right, this is a horizontal question because the tunnel's going this way. So you turn in a horizontal angle here, here, and here. It's not a vertical angle like going up a mountain. Tunnel is to be dug from A to B and are visible, blah, blah, blah. If AC is 1.41, blah, 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 and BC, AC is here, BC is 1 point, blah, 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 and C is 90 degrees, find the measures of angles A and B, but I'm going to find everything. Okay? All right, get to it. We'll do this one, and then we'll jump back into 8.4 and finish up 8.4.
Hey, Hubert.
Yes, sir.
It's stores. It's still kind of messing up for me. If I left the call, could you call me back?
Yeah. Okay, go ahead and leave, and I'll bring you back in. Miss Fuller, did it ever start working with you?
It worked for a second, but it's back off again.
All right, I'm going to remove you and bring you back in, okay? That usually helps. So I'm going to take you out and bring you back in. Hopefully that'll help. See if that'll help now. May take a second. On your internet service and where you are and all that stuff. So draw yourself a picture. Draw yourself a picture. And I'm going to draw my picture over here where it's wider. I'm not going to draw it like. So we've got a 90-degree angle here. And we'll just go ahead and label it. This is C. This is A. This is B. They don't give us those angles. All they give us is A to C is 1.4145 and 1.1137. Now you don't have a choice here. You've got to use what? What have you got to use before you can even get started?
Pythagorean theorem.
Good. So 1.4145 squared plus 1.1137 squared is equal to C, and I'm going to take the square root of that, and somebody just tell me what it comes out to be. Okay, I got a 3.24, give me 3. Since these are 4, I'm going to need 4 decimal places.
It's
What? I don't know who's right. I just heard 3. 1.8 what? 003. All right, now let everybody check to see if that's what everybody got. Skype people?
I got the same thing.
Okay. All right, we'll call it 1.8003. And now you have what you need to start doing your trig. So, just pick something, I don't care. Sine of theta is equal to, sine is equal to, we're doing A. I'm going to do A. I'm going to put my little man on A. So that means this is the hypotenuse, and this is the adjacent, and this is the opposite. So sine is equal to Oscar hat, so 1.1137 over had 1.8003 divide by the sine, bring the sine up over here, that cancels. Theta is equal to the inverse sine of 1.1137 over 1.8003, and somebody tell me what that is. Theta equals, I'll just take a decimal degree. So just give me, it says round to the nearest thousandths, tens, hundred thousandths, so 3 decimal points. What do you get? I heard woo, 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 woo. Try it again.
I think it is 38.215.
Okay, I heard that. 38.215 degrees. All right. Anybody else get that? Need somebody else to get it, same number. If not, then we got to try something else.
I got the same thing.
Okay. All right, so that one is 38.215. So that means that our degree up here is going to be 51.785. Somebody check me. Somebody check my numbers. I hear 1 yes. Somebody check it for me. Need 2. It always helps to have 2 people confirm. How about it, Skype people? Did y'all get 51,785?
Yeah, once I added it.
All right, so what are they asking for? They're asking for angle A, so that's 38.215. So I'm going to type in 38.215. And that's all. Angle B is, this is a good test question, 51.785. I can guarantee you're going to see one of these that has anything to do with surveying. Check it. We got them both right. We smart. All right, I'm going to get into these today. So I'm going to go ahead and go to the handy dandy PowerPoint. And we're going to, where we left off yesterday. And here's where we left off. Now, I am not a big proponent of the Bessel theory as far as, testing you on it, but it basically is what we're working on right now. So you might want to take a picture of this or, just watch the video 2 or 3 times. It's not that big of a deal, but I'm going to show it to you. Where is the slideshow? Present. Write it down if you want to. It's not really much of a definition. They're just saying that the angle that you're going to be using is not A. It's basically going to be what? B, because it's coming from the star. So that means that your adjacent now is your what? Opposite. And your opposite now is your what? Adjacent. So that's the only difference between the problems that we're doing now and this problem. Okay? They will probably give you D, which is your hypotenuse. Okay, so I guess you could write under this as far as notes, under distance to a star, 1. Adjacent is equal to opposite, and opposite is equal to adjacent, and given hypotenuse. Okay, which really doesn't matter because now I've shown you basically how to do everything with the problems that we did the other day and these 2 problems today. That's why it's so important that when you do a problem, not like my son will walk through the kitchen and there'll be a piece of paper on the floor and he'll walk by it. Not if I catch him, he won't. Okay? Why? He should pick it up. Now, is that something he's supposed to do, or is that something he does? Well, when you're talking about math and science, well, anything you do, you get out of it what you put into it. If you suck at working on this stuff, you're going to suck on it on the test. It's as simple as that. And I know that goes against everybody gets a trophy, but that's the whole purpose between first, second, and third, is for people to work their butt off to get that A. All right? If you do every one of these problems, and instead of just finding what you need to find, go through and find all 5 or 6 parts, when the test rolls around, you're going to be good to go. And I'm not just meaning for this class. Calculus, physics, statics, dynamics. Okay? So this is just something else, something, for you Jeopardy folks like I am. Some kind of bezel, dang old star. Okay? And here's a problem. One of the nearest stars is Alpha Centauri, which has a parallax of theta is equal to 0 degrees, 0.2 seconds. I'm sorry, 0 is a decimal, 0.000212 degrees. Calculate the distance to Alpha Centauri if the Earth's sun distance is 93,000 miles. All right, do that. Draw a picture. Let me get we can use this. I found out the other day. I don't know if y'all saw that. We got it. That makes things a whole lot easier. This is not the board. This is PowerPoint. It's a whole lot nicer because you can't bring in PowerPoint and the other things. So they have PowerPoint has its own little. I'll shut up. So here's your star. Here's your sign. There's your star. Here's the center of the Earth, or center wherever they shoot it from, and here is however they want to draw it. And they're giving you 93,000 miles, or 93 million miles. And they give you this angle as 0.000212, 0.000212 degrees. And I don't even care what they want because I'm going to find everything. So, since they give us this angle, my man is sitting up here. and he's got his foot on the adjacent and the hypotenuse. So that means this side is the opposite. So, I'm just going to pick the sine. Sine of 0.000212 degrees is equal to Oscar had. So that's going to be O over 93 million miles. And of course, 93 million miles times the sine of 0.000212 degrees is equal to the opposite. Oops. So I'm going to take my handy dandy calculator. Second entry, and I'm going to take my delete button and delete this and put insert, second insert, 93, comma, 123, comma, 123 times the sine of 0.000212 second the angle degrees, close parentheses, and enter. Okay, something. Oh, I know. Doesn't like the commas. How do I get back in and edit it? Second entry. Take the commas out, Hubert. Don't like commas. There we go. 344.1011. Is that what y'all got? Okay. Sorry. What did we get? 301? 11 or 12? 11? 344.11 is equal to, all right, cosine. And now you can basically skip this part, but 930 or 93 million times cosine of 0.000212 degrees. And that's going to be equal to what? The adjacent. So what is that? When you do the math, what do you come out with? Or, if you did the Pythagorean theorem, 93 million miles squared minus 344.11 squared, get that number and then take the square root of it, should be the same number as cosine of 212 times 93 million. So what you come up with? I'm waiting. It's too much trouble for me to go over there and do take the thing down. So what is it? Well, y'all should have already had it. Well, I give y'all extra time.
I would have got some huge number.
It's going to be a huge number. Look at your picture. It's going to be less than 93 million, but what is it?
I got 92,999.99.
Okay, 92,999,999.
Well, it would
What?
round up. It would then it was 36332.
Right here, 36.
Yes, 36332.
Well, it can't round up
No.
to 92. It would be this.
I'm sorry, I told you wrong. Okay. I can't see you in the way. I
Okay,
can't
is
see
that,
what you wrote.
is that your answer?
What? In front of the 362, it had 3 nines.
39362.
Yeah.
39362. Three, 9, 3, 6, 2. All right. What about Skype people? Did you get that? Okay, they went back to bed. Yes. Got 1 yes out of 5. All right. Now, what's the lesson here? When this angle is very small, these two sides, side hypotenuse and adjacent, are going to be just about what?
The same.
Just about the same. When you have a very, very, very small angle, the adjacent and the hypotenuse are going to end up being about the same. When you're dealing with that angle of theta. All right. Now you can figure the angle down here by subtracting it from 90, and that's going to be 89.997 or 788. Somebody check me. It's going to be, I don't forgot what I said now, but 89.999788. See what y'all get. Yeah, Hubert, that's right. No, Hubert, that's wrong. Hold on. I'm trying to turn my calculator on. 230. I'll get the calculator up. At least I know I don't have any calculator drill team members in here. 90 degrees, second angle degrees, minus point, what was it, 0.0002, what was it? 212.
Yeah.
Second function, matrix, degrees, and enter. Is that what I said?
Yeah.
Okay. I'm glad I checked myself. Yeah, feel free to check my work, and let me know what the number is. That would be appreciative. So that should be all the questions they're asking. Now, B. A light year is defined as blah, 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 travel, blah, 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 5.9 trillion miles. Find the distance to Alpha Centauri, so whatever, in light years. Okay, calculate the distance to Alpha Centauri. If the Earth-Sun distance is 90, calculate the distance. Evidently, they're talking about like a rocket going straight up. So they're talking about going, are they talking about going, I guess they're talking about going this distance. Light years to find the distance, light travels, find the distance to Alpha. Okay, they need to specify, but a rocket don't take off at 45-degree angles or 89-degree angles. It takes off from here. So I would assume they're talking about this distance. So what is this right here? Tell me what this unit is on this 92,999,999.4. What is that?
Distance from the star.
Which is in what? Okay, so
Uh,
put that over 1. We're going to do a unit conversion here. I guess I'll have to do it at the top. So we've got 92, 999, 999.4. Yeah, 0.4 miles over what? 1. Now we got to have miles on the bottom so we can what? Cancel, Hubert. So it says 1 year equals 5.9 trillion miles. So 1 year equals 5.9 what? Trillion. So miles cancel and you're left with a year. So you take 92, 999, 999.4 and divide, well, trillion is 1, 2, 3, 1, 2, 3, that's million, billion, and what? Trillion, so that's 0, 0, 9, and then 5, right? Did I do that right? No. Well, 1,000, trillion, billion, million, billion. Okay. All right. So somebody do that for me. I'm sorry, what?
There's 4 zeros, 1 6.
0.0000 what?
1 6.
Now, if you want to know how many hours that is or whatever, does it ask for hours? No, it just says light years. So I would assume that's 0.00016. I don't know what they, but if you wanted to do it, let's say days. So that's 0.00016 years over 1. So how many days are in a year? So multiply this by 1, let's see, 365 days are in what? 1 year. So the years would cancel and you're left with days. So somebody take 0.0004016 and multiply by 365, see what you get.
0.00584.
0.00584 days. So you would have to take that on down to what? Hours? Because, you know, there's 24 hours in a day, right? So 0.0000584 days over 1 multiplied by, there's 24 hours in a what? Day. Days cancel. So multiply that by 24. What do you get? 0.000584 times 24.
0.014061016.
0.014061016.
016.
016, these numbers do not look good. They're too small. I think that 5.9 trillion is wrong. Let's just see what they did, because I think I counted too many decimals on that 5.9 trillion. But I may be wrong. Let's see what they did.
3 numbered 5.
No, I think I'm 1 digit off. Where is my, there. Okay, did we get the right number there? 2.51 times 10 to the 13th. Did we do that right? That don't look right. Let D be the distance between Earth and Alpha. We did something wrong. No, you shouldn't. No matter where I put my angle, I should have got the same thing. Sine is equal. Opposite. Sine Oscar had would be the opposite over the adjacent. Oh, wait a minute. 93. Oscar had. Yeah. Sine is equal. Well, they're putting the sine. They're putting the angle right here. Still should be the same thing. Let me check and see if. Let me check the calculator, because evidently I typed in something wrong, or let me see what the last thing I typed in was. Second entry. There it is. 93 up here. 93 million times the sine of 0.000212 degrees. Oscar had. That gives us 344.11. If you take 344.11 and you square it and take it away from this, you should get some number like this, but they're not getting that. Let me put it where theirs is. They're saying right here the sine Oscar had would be A over 93 million. Isn't that what they're doing? Okay, I'm confused. They're putting the hypotenuse over D, which is the adjacent.
If you square that number and take it away from that 93, whatever it is, you get like 92.
I know. No, I'm confused with what they're doing here. Somebody help me out. Maybe I've been teaching too much this morning. What is 93 million? Is that not the hypotenuse? Okay, yes or no? Oh, wait a minute. As the Earth revolves around the Sun, the observed parallax of 61 sine is theta. Well, that's this one right here. That's to the Sun. Okay, I'm totally. Sine is opposite over what? Oscar hat. Okay, that is not the opposite, unless I'm looking at something wrong. Okay, it says from the Earth, let D be the distance between the Earth and Alpha. Oh. Okay. I read the directions wrong. I thought that this, there it is right there. My mistake. It's what happens when you don't read the directions very well. And who's the worst at reading the directions? Men. That's Earth what? Yep. So I totally botched that one up. So just ignore what we just did. We'll do it again. Right now I'm irritated with myself, so I don't need y'all to be irritated with me. I'm very irritated, so just let me just erase this. Oh, I got to erase it on this other thing. Hold on. Very irritated. Maybe it's the medication. Okay, erase. What are you doing? Go ahead and draw another picture of it. Please. While I try to erase this screen. Oh my Lord, just forget it. Well, let me erase it. Just keep doing this. All right, we'll just draw it on this one. I'm sorry I messed up. That's what happens when you don't read the directions. All right, so let me start over. Star, sun, earth. This distance right here from the earth to the sun is 93 million. $93 and the angle is 0.0002, which is up here, 0.000212 degrees. So we're dealing with the opposite down here. Oscar had sine of 0.00212 is equal to opposite over what? This right here? No, that'd be opposite, which would be 93 million over Oscar had. Okay? Now, first of all, to get rid of this, we've got to clean it up. So I'm going to go up here and I'm going to put sine of 93. I'm just going to put 93 if that's a sine of, I just can't do anything right today. It would help if I didn't have to go through all these tricks just to write on the board. That's what happens when you use dang PowerPoints. Okay, sine of 0.00212 is equal to 93 million. I'm just going to put 93 over h. So multiply both sides by h. And we get h sine of 0.00212 is equal to 93. And then divide by what? what do we need to do to get H by itself? H is equal to 93 divided by the sine of 0.00212, and that should be what they have. Yep, right here. Okay? So take 93 million and divide by the sine of 0.00212, and that'll give you this number right here, which is the hypotenuse. And now you can find this side right here, which is the adjacent. You've got the hypotenuse. The hypotenuse is equal to 2.5 times 10 to the 13th. And the adjacent comes out to be, well, I guess they don't really need to know. Yeah, they just take that number. They're taking this number from the earth right here. And they did just like I said, distance equals rate times time. So you put 2.51 over 5.9, and you can just do your 2.51, put this in the calculator, 2.51 over 5.9, and then 10 to the 13 minus what? 12. So what's 2.51 divided by 5.9? I'm sorry, what? 0.425. And 10 to the what? First. So move that one place to the right, 4.25 light years. I'm sorry about that, but I knew something was wrong. I knew something was wrong when we were getting 0.01 days. That couldn't have been right, or 0.01 hours. I knew something was wrong. I just didn't know what was wrong. And when I saw that sign, and that's the hypotenuse, I thought that was the hypotenuse, I said, something's not right. And then I went back to the question, and I did what a lot of males do. I didn't what? I didn't read the direction. I thought that was the Earth star distance. So I thought this was the hypotenuse. Does everybody see where I made my mistake? Okay, one person said, Skype, sorry about that. Did y'all see where I made my mistake? They didn't go back to sleep.
Yeah.
Okay, one person. Okay, so one person out of 5 here, and one person out of 5 here talks. Okay, let's get away from this one. I wouldn't give you this one on the test anyway. I give you the surveying questions. I will give you one of these, though, because you're going to see this one again in Calc 2. All right? Write that one down. You don't have to, you call him Fran. I don't think you need to write out Francisco. Fran. Now, you ever been on Facebook and you see this drawing and they say how many triangles are in this drawing, or how many? Same thing here. How many right triangles are in this drawing? Two. There's 2. And you need to see that because that's how you do the problem. Similar triangles. So I'm going to take my handy dandy highlighter and I'm going to highlight it green. Okay, this thing is getting on my nerves. It's working fine until I ask it to do something. And here is your first triangle. That was a stupid color to use. Let's try yellow. I'm about ready to quit. Whoops. Y'all ever had a day like this?
Yes.
Okay, I hope y'all can see that yellow. I hope you can. All right, there's one triangle. And I'll do the other highlight in that blue color. And there's the other triangle. So you got two triangles. One triangle. I'm going to do this in yellow. I'm sorry, but I know it's going to be hard to see. That's the little triangle. It's got a 36-degree angle, 36.7 degrees. And I don't know if we have any, I don't think so. I don't think there's any other, got a height here and X here. And then our blue triangle is a little bit longer. And it's still got the H here. But the bottom right here is not X, it's what? 50 plus X. Or X plus 50. Doesn't matter because it's addition. And this angle is what? 22 degrees, 22.2 degrees. Now let's make sure, I'm going to read the directions again. Just making sure I don't mess up this time. Francisco needs to know the height of the tree. From a given point on the ground, he finds that the angle of the elevation to the top of the tree is 36.7. He then moves 50 feet back from the second point. The angle of the elevation is 22. Find the height of the tree. Oscar had a hump. I would probably go with the cosine. Why? Well, you have 50 plus X as what? As the adjacent. You have X as the adjacent. You don't have anything else. And there's nothing. So you got to use what you got. And the only thing you got is X and 50 plus X. So there'd be no reason to use the hypotenuse. Because that would give you another what? Unknown. So the only thing you have is the angle. So we got to put a trigonometric function with it. Cosine, oops. Cosine of, I'll just go with the first one, 36.7 degrees is equal to H over X. And the cosine of 22.2 degrees is equal to H over what? 50 plus X. Y'all see what I'm doing? Okay, so I'm trying to use what we've got. And this is what we've got. So I'm just going to put this in a little section right here. And then I'm going to say, well, maybe we can use the Pythagorean theorem somehow. But you can't because you don't have any sides. So you're going to have to rely pretty much on these two things. What if we decided to get H by itself on each one of them? Then we can set them equal to what? Equal to each other. So solve this one for H and solve this one for H. So multiply both sides by x here. So h on the top one is equal to x times cosine of what? 36.7 degrees. And multiply by h on both sides, or get h by itself here, and you're going to get h is equal to x plus 50 times cosine of 36.7. I'm sorry, 22.2. Now we can set them equal to each other, because each one of them equals what? So we can set these two equal to each other and solve for x. So do that. Now remember, what's cosine of 36.7 and cosine of 22.2? What do they come out to be? Numbers, right? So you just got numbers with a algebra problem. You got x's and numbers. Algebra 1. We'll go up here and show you what I mean. X times cosine of 36.7 is equal to x plus 50 times cosine of 22.2. Well, these are numbers. Somebody give me the cosine of 36.7. What do you get? Make sure you put your degrees. The cosine of 36.7 degrees. What time is it? We got to go. Well, we'll finish this later. I'm going to go ahead and cut it off because other people are going to break down the door. So we'll finish the unit next week then, because I screwed up today. Hope your teeth feel better. Okay, Skype people, we're going to finish the unit probably Monday or Tuesday, okay?
All right, yes, sir. Sounds good.
Y'all have a good weekend.
Yes, sir.